Since I started to make YouTube videos, I've been constantly running out of space on my PC. My home server rack project alone actually took over 90 gigabytes of video footage on my hard drive, and my recent decision to make all future videos in 4K, that didn't make it much better. So that's why I have decided to do things right, and I've built a new massive storage server that gives me enough space for all my video files and other stuff that I'm storing in my home lab. This new server has 48 TB of storage capacity, it just looks awesome in my new home server rack, and it's all based on regular desktop hardware inside. So even when this looks like a professional server, it's all built by myself. And even though I'm probably not the most knowledgeable person when it comes to storage systems and hardware, I'm still proud of it. And I want to share my experiences with you and want to show you how I've set up this one. I will also show you how I've installed TrueNAS Scale, a free and open source operating system for NAS systems. It's absolutely amazing. So if you're planning to create your own NAS server at home, I hope it will help you. So let's get started. To be honest guys, this video was so much more work than I've expected. I've done so many things wrong and I've had so many problems and issues that I all needed to fix, so that's why this video took me such a long time to make. However, I also think it's always the best to learn from mistakes, so I hope to give you some tips and advices you all need to take in consideration when picking the right hardware parts for a project like this. And of course I will tell you what I've learned during this project so that you avoid making the same mistakes like I did. By the way, if you want to have a list of all the components that I will explain here in this video, you should take a look at my kit page. There you will find lists and builds for all my servers, hardware and also other equipment. But before we start, I also want to show you a nice tool to secure the access to your critical infrastructure and servers. Some of you might already know it, it's Teleport. With Teleport you can protect remote resources like SSH, Linux servers, Kubernetes, databases or web applications with two-factor authentication and an audit logging. Teleport is entirely open source and free to use in the community edition, and suppose you want to use it in your company environment and secure your development or operations teams, in that case they also offer an enterprise version with additional 24/7 support and single sign-on. It's a great application, so just download and try it out. Of course you will find a link to their website in the description down below. Okay, so what did I get to build a storage server like this? I've ordered so much stuff that I completely lost track of it, but that's why I have my notes here. So let's start with the server case, because this is the first thing that I've bought, and this is also the most important one, I guess, because it somehow decides how big the motherboard and the power supply can be, how many hard drives you can put into the case and so forth. So this one is the Intertek 4724, a 4-unit rack case that's relatively new and just looks incredible if you ask me. I've not found anything else comparable for this price, so it costs around 500 euros, but it comes with 24 bays for 3.5-inch hard drives and a built-in backplane to connect them all to a storage controller. Absolutely amazing. I will only use half of the bays though, because I could just afford 12 hard drives, but I wanted to have some additional upgrade potential if I'm ever running out of space again. Intertek is a German company and they offer a wide range of computer cases like regular desktop PCs, rack servers or storage cases in different sizes. I don't know how well you will find these cases outside of Germany, like in the US for example, but if you find them, it's absolutely worth taking a look at their cases. I also used an Intertek case for my Proxmox servers in my server rack, and they were all pretty good, so I was really excited about this new storage server here. Next we have the Mainboard, the ASRock X570 Pro 4, and this is a regular desktop motherboard and supports AMD Ryzen CPUs in the latest generation. I've mainly done this because I wanted to keep the budget in a range that I can afford. I actually thought a lot about buying a real server mainboard from Supermicro for example, or using Intel Xeon or AMD EPYC CPUs, but anything in this range would cost at least twice the money, maybe even more. And I thought, why not use regular desktop hardware? You can build very powerful and efficient systems with AMD Ryzen CPUs. Sure, you don't always have the same features like in a real server mainboard or professional server equipment, and I would never do this in production or company environment, but when you plan it the right way, you can definitely find a setup that fits your needs in a home lab. However, you need to be careful with your mainboard and CPU choice, because the lower chipsets of desktop motherboards are most likely limited when it comes to PCI slots and lanes, and that can have a dramatic implication on your performance. My experience is that it works pretty well with the higher chipsets of these desktop motherboards like this X570, but just keep that in mind. That's where regular desktop hardware might have some limitations compared to workstation or professional server hardware. And as always, it of course totally depends on your setup and needs. For me, this one works pretty well. The next part is the CPU, and that's where I did a pretty big mistake in the first place. I just talked about PCI slots and speed, so I thought it's a great idea to not waste another PCI slot on a graphics card. So I wanted to be smart, and I ordered an AMD Ryzen 5750G, the fastest Ryzen CPU that I could find with an integrated graphics chip. It has 8 cores and 16 threads, and while these CPUs are great for desktop usage, they don't seem to be a good fit for NAS solutions. Their main problem is that these Ryzen G CPUs usually don't support ECC memory. So I ended up switching this CPU with the AMD Ryzen 3600, which is a bit slower than the other one because it only has 6 cores and it's a bit older. But I guess for a NAS system, it's not really a big deal how fast the CPU is. If you're not running any extensive workloads and you don't use deduplication or things like that, it should be okay. The AMD Ryzen 3600 absolutely does the job in my scenario, and the great thing about AMD CPUs is that, at least the ones without the graphics card, they most likely all support ECC memory. And speaking about memory, I've bought 32 gigabytes of unbuffered ECC memory, and I also got another 32 gigabytes of ECC memory out of my Proxmox server build because I don't need it there anymore. Together I now have 64 gigabytes of ECC memory for this storage server, which might seem like a lot, but if you're building a storage server with ZFS as your file system, it is exceptionally useful to have a lot of memory, especially when you're doing a lot of read and write operations on your NAS. And that's because ZFS uses the memory as a cache for reading files. So when you're copying a file, it goes into the memory cache, and that improves the overall performance significantly. Reading files from the memory cache is much faster than reading files from any hard drive, including SSDs or NVMEs. And then 64 gigabytes starts to sound reasonable for a NAS build like this. You probably could get away with less memory, of course, but I wanted to be safe in this case because I transfer a lot of big files frequently when I'm doing video editing. Also, getting ECC memory was important for me. For some reason, a few people keep telling me that ECC isn't necessary for ZFS. Look, I've heard many different opinions on this topic, and there seems to be a big discussion on the internet going on about ECC and ZFS. But what I've learned about data integrity in servers is that ECC is always helpful in case anything goes wrong in the memory. That's not really specific to ZFS or any other file system. And because TrueNAS, the vendor of this operating system, also recommends ECC memory in their documentation, even though some people believe this isn't the case, I still prefer using ECC memory whenever I'm building a storage server because it just seems to be the recommended way of doing it. I can't really understand why people are fighting so hard about this topic, but yeah, probably the same reason why people fight about operating systems. Okay, so now to the hard drives, and this was the most expensive part for this build. I've added 12 4TB Western Digital RAID drives, which give me 48 terabytes of storage in total. So I'm not able to use all of it, because in ZFS I will reserve some space for redundancy, of course, but that still should be more than enough to store my video files for many years. I decided to not pick SSDs because I wanted to see how fast a NAS system would be with regular HDDs. And that's also the reason why I preferred using 12 4TB drives and not 6 8TB drives. Because the more drives you add into a single storage pool, the more performance you get out of it. Keep in mind, it is different depending on which operation it is, so if you're reading or writing files, of course, and how many drives you're using for redundancy, but I'm very happy with the performance. By the way, I will show you some tests later and also talk about the network throughput, because in a usual network, most likely the hard drives aren't the real bottleneck here. it is your network speed. Next we have the storage controller to connect all these hard drives, and this gave me a lot of headache because storage controllers in these sizes are freaking expensive. Just take a look at some of the Amazon links when you're searching for SAS controllers with many ports. It's mind-blowing. So I thought a lot about what I should do. So should I maybe just connect a few smaller 4-port or 8-port SAS or SATA controllers instead of a big one? However, because I wanted to use a regular desktop motherboard, I wouldn't have enough PCI slots for more than one storage controller, so I needed to find one cheap controller with many ports. And I found this Adaptec ASR controller here that I got, and this can connect 16 SAS or SATA drives. It also has a so-called HBA mode that you absolutely need for a ZFS build, and I also got this controller really cheap on eBay. So if you're searching for controller cards, take a look at some used or refurbished models. Most people are reselling those used controller cards they ripped out of bigger enterprise servers. Always take care of their specifications and do a proper research if the controller does everything you need. But if you know what you're looking for, eBay is always a great resource for finding these controller cards or other server builds in general. For the operating system, I also bought an NVMe drive, the best option in my opinion. This one I got is the Kingston A2000 with 1 TB, so I just put it on the mainboard. You don't need an additional slot or SATA cable here, and it's blazing fast. Nothing really special. But as I said, when it comes to performance in a storage server like this, the hard disks probably aren't the main bottleneck, because in a usual 1 gigabit network you can transfer approximately 110 megabytes per second, which is already slower than a single hard disk is capable of. And because I'm using ZFS to combine all 12 hard drives to increase the speed even more, 1 gigabyte simply isn't fast enough. So I bought a 2-port SFP plus 10 gigabit network card. This one is an Intel X520DA2 chip, and these cards work very well. I've already tested them on my PC and in my Proxmox server. And I added a 2-port card mainly because they aren't so much more expensive than a single port card, and then I can connect one port to my network switch and another port directly to my PC to transfer files with 10 gigabit speed. Of course, the speed that you really get out of this depends on many different factors, like if the file is in the cache of the ZFS file system, or if you're transferring a lot of small files, then it always gets a bit slower. But I want to talk about this later in a bit more detail, so just know that when you want to get the most performance out of a storage server, you probably need 10 gigabit. Okay, let's also talk about the power supply, and that is a great advantage when you're using desktop PC hardware in a large rack case like this. You can just get usual ATX power supplies and regular desktop fans. And I always get fans and power supplies from Be Quiet. They are really great. So I got a 600 watts pure power 11 from Be Quiet, which is modular, and this will be directly connected to the backplane inside the server case, which will then also power all the hard drives. I needed to get some adapters to connect it properly, and it looks like a complete mess inside, but it works. I also changed the default fans in this case because they were pretty loud, so I ordered 3 regular case fans from Be Quiet. They are very silent. One thing though I need to say, I had a few problems with the backplane where these fans are connected to, because usually the backplane controls the speed of the fans, but I realized this somehow didn't work. They were just running on a pretty low speed. And I was really surprised by how much the cooling matters when you put a lot of hard disks so close to each other. After attaching the fans to a separate fan controller and raising the speed to maximum, the hard disk temperature went down 10 degrees, which is a lot. So good cooling in a storage server like this can also make a difference. Okay, so I now talked a lot about the hardware part. Did I ever say that hardware isn't my favorite topic? I mean, it sometimes makes fun, yeah? And I really like building the home server rack and the storage server, but it's always the less enjoyable part. I'm always more excited about the software inside. So let's now come to this part, and that also was a bit of an experiment for me because I'm running an operating system on this storage server that I haven't really used before. And it might be pretty interesting for anyone who wants to use this in a home network, because I believe this system is probably the best operating system for any home lab or self-hosting projects. People who watch my videos already know I'm of course talking about TrueNAS. And TrueNAS has always been a great choice for NAS and storage systems. It's undoubtedly one of the most reliable and powerful systems out there. And I've worked with TrueNAS on my Proxmox server as a virtual machine for quite some time, and I always have been very satisfied with its quality. But IX Systems has also released a new version of TrueNAS, which is called TrueNAS Scale. And even though the web UI and the core functionalities are very similar on these 3 different versions of TrueNAS now, it is a complete different system under the hood. TrueNAS Core, which was formerly called FreeNAS, this is a free and open source operating system you can use on a single node storage server. It comes with all the features and functionalities you need on a NAS system, and it's a very reliable storage system that's based on FreeBSD and comes with a ZFS file system, which is absolutely amazing. And it's really an enterprise grade operating system and known for its stability and reliability. But then there's also the TrueNAS Enterprise version, which is the commercial license of TrueNAS, and that also adds some new features that are interesting for companies like high availability or enterprise support. And they now also added TrueNAS Scale, which follows a slightly different approach, and this is called a hyper-converged compute and storage system, which sounds complicated, but what it actually means is that this system is a multi-node edition, so it's made to be used in networks where you can easily scale out your storage systems by adding more nodes to the cluster. And that is probably a very interesting feature for data centers and companies where you don't run single node systems or you dynamically need to expand your infrastructure. But it is also interesting for developers. And this is the reason why I believe this is so great for a home lab solution, because it is not based on FreeBSD anymore, it is now based on Linux. And this alone wouldn't mean much, but this now allows TrueNAS Scale to add a bunch of different features we already know from a Linux operating system, like Linux containers with Docker and Kubernetes. And I don't think I need to say how important containerization in Kubernetes is in IT. I've made so many videos about these topics, and I guess most of you will already run containerized workflows in your home labs. It just makes things easier for us, and it's also the technology that is used in big enterprise companies. I think IX System is positioning themselves in the right direction with this move, because cloud-native technologies and containerization is a big trend in IT, and it just totally makes sense to have these features on a NAS system. So I don't want to dive too deep into this, I just want to give you a brief overview of TrueNAS Scale and show you a few things, how I'm using this as a storage server, but I will, by the way, of course, make a separate video about it and talk more about these modern and new features like Docker and Kubernetes. So if you haven't subscribed and liked the video, then do it now. That would be great, because it's really helping out the channel. Now let's take a look at the web interface of TrueNAS Scale. So once you log in, you can see this looks very much the same as TrueNAS Core. It has a different menu, so some items are organized slightly different, but the dashboard looks pretty much the same. And I absolutely love the web UI of TrueNAS Scale. I think this gives you a perfect overview of your system, and it has a very clean look. For example, you can see in the dashboard the current CPU model and load, the network throughput and the memory. And as you can see, ZFS is a pretty memory intensive file system, just like I told you. I still have left a bit less than half of the memory I have in the system, but just imagine I would want to run some virtual machines on this server as well, or some containers. So overall, I think it was a good idea to invest in some extra memory. For the storage, I've created one big pool on this server, and this is the first thing that I want to show you, because when you create a NAS system like this, you of course want to have a reliable storage that combines all the separate hard drives into one big pool. And this is what you can do with the ZFS file system of TrueNAS. The storage pool that I have created uses a storage capacity of 11 hard drives, so I'm not having 48 terabyte of storage, I only have 44. But the big advantage of this is if one hard drive is damaged, my data is still there. That's because the ZFS file system can add redundancy to your storage pool even without using any hardware RAID. And it's also a significant performance improvement depending on how you're setting it up. As I said, in my case, one hard drive can fail and the data is still there, so this is what it's called a RAID Z1 storage pool. Now, there are many other options and possibilities to configure ZFS, and I don't want to go into too much detail here because I've already explained this in my old video about TrueNAS Core. So if you don't know about ZFS or TrueNAS and this is the first time you're using it, you can still watch this video. I've put your link to it in the description down below. So I created also some data sets on this storage pool, and here you can divide the storage pool into separate sets where you specify different compression settings, quotas or snapshot tasks. And this makes totally sense in my opinion if you want to create different network shares. For example, I've created some shares for my Windows operating systems by using SMB, which allows me to access this storage from my workstation PC and use it as a network drive. And then I also added some NFS shares for my Linux systems, and I believe this is a perfect solution to store data for your container volumes or store backups of your virtual machines. Now you might wonder, how fast is this storage server when you copy a file over the network? And as I said in the introduction, it depends a lot on your network connection speed. So that's why I have connected the server with 10 gigabit. I'm using a 10 gigabit card with 2 ports here, so I have 3 different network interfaces on TrueNAS. The first is the onboard 1 gigabit card that I just use as a backup management port. The second goes to my network switch, and the third goes directly to my PC. That's probably the easiest and fastest way to connect the devices, because there's nothing in between which could interfere the connection. And I've first done some tests with iPerf to measure the throughput of the network speed, and I would always follow this logic. So first, check the speed of your network connection with iPerf. This is the easiest way how you can find out how fast your network will transfer the data in the best possible solution. The iPerf tools should be pretty accurate when you're connecting 2 devices directly, and they work with both TCP and UDP. And as you can see in my example, it's almost 10 gigabit when I transfer data from my PC to the server. And when you do the same tests over the second network card, which is only connected with 1 gigabit, you can see the difference. And the 10 gigabit connection works in my setup without any further settings or tuning, so I just mapped the network drives and I did some file copying tests. What's pretty interesting to see, when you copy a file from the storage server to my PC, the first attempt doesn't quite get up to 1 gigabit per second, so it's not utilizing the entire bandwidth that should be possible, but this is most likely because the hard drives aren't fast enough to read data with 1 gigabit per second. But you can see it's actually not really bad, so it's still around 600 to 700 megabytes per second with 12 hard drives in RAID Z1 storage pool. That's already good. But when you now copy the same file again, it gets faster, even up to 1 gigabyte per second. This is as fast as it can be in a 10 gigabit network, so it's now utilizing the entire bandwidth of the network card. And this is because the ZFS file system has put this file already into the memory cache once you copied it the first time. And whenever you access the same data again, it's not reading it from the drives anymore, it's now reading it from the memory. That's why we get these incredible fast reading speeds now. You can even check that in the TrueNAS Scale reporting, so how frequently and how fast TrueNAS is reading the data from the actual drives. The reporting in TrueNAS, by the way, is outstanding. It's awesome to get a better understanding of what's happening inside the system and how the NAS system operates. Sure, it might take some time to understand what all these reports mean, but it's great to measure the performance, check the CPU and the memory utilization or the temperature of the hard drives. And what I can tell you so far after doing some tests with this system is that TrueNAS ZFS works very performant out of the box. I've not added any SSD or cache into the system. However, you should consider this works very well in my current workload as a file storage, so I'm transferring a lot of big video files or backup data. Keep in mind that SSDs or NVMEs can still make sense in other scenarios. So for example, if you plan to use it as an NFS share for virtual machines or container, here it probably is a bit different, so just keep that in mind. I guess for a file sharing system this setup is great. It might not be the best for a different use case. Anyway, however you plan to use your storage server, it is always very important to back up this data, so I also added a snapshot task that keeps a daily state of the entire storage pool for 2 weeks. So that is great. If you accidentally delete some data on the network drive, you might need to restore the entire pool or the data set. I'm also planning to set up an offsite backup for this storage pool, because if anything goes wrong with the entire server, I might still lose the data, even with snapshots. So I'm considering uploading this all to a cloud drive, which isn't free of course, but that might be a good option as well. I know there are so many more topics we can talk about when exploring storage systems and TrueNAS. You can do so much more with it, but I guess this video is already pretty long, so I will just stop at this point and put some of the topics aside for next videos, because I want to cover the Kubernetes part in TrueNAS in more detail and show you that in a second video. But I hope this still helped you to get some ideas and inspiration to build your own NAS system at home, especially when you're planning to use it as a storage solution. And as always, thanks everybody for watching. I will catch you in the next video. Take care. Bye bye.